Yeah, so the research that I'm presenting today focuses on the application of a multi-user computer-aided design, or CAD software, on the future of engineering education. And CAD modeling has played like an indispensable role in the modern product design process, providing a technical visualization of the product before actual manufacturing. However, traditional CAD software requires time-consuming file transferring between members of the design team. So this new multi-user CAD software builds a collaboration platform for simultaneous CAD modeling between geographically distributed engineers. And we have paid attention to its potential of improving the efficiency of collaborative engineering design, and also its opportunities to improve engineering education, as CAD modeling and team collaboration are both important for engineering students to learn, especially in mechanical engineering. However, insufficient research has been conducted in the field of collaborative learning with cloud computing tools, especially on CAD modeling. So our research examines the feasibility of applying a collaborative CAD platform for engineering education by grouping students for an open challenge. And our research is primarily conducted on Onshape, which is a commercially available web-based multi-user CAD software. And its web-based nature allows it to be run on devices with any operating systems. Also, it records real-time analytic data for our research purpose. And here in Figure 1, it shows a typical routine in like a typical design routine in Onshape. So starting with a 2D sketch in a Part Studio, users then create 3D solids based on the sketch using different Part Studio features, such as extrude, revolve, or sweep. And after making all those parts in a Part Studio, parts are then put together in an assembly using like there are many assembly features available to create different relations between parts, such as a fixed mate connector, a slider, or a revolute. After all, rendering can also be done by dragging parts around and creating animation in an assembly. So the methodology that we propose here consists of both quantitative and qualitative analysis, with back-end analytic data automatically collected by Onshape. Like all the actions that were made by every CAD user in the software are recorded as an audit trail. And by going through all these possible data types, we have isolated all the constructive actions that make real changes to the design from other non-essential actions, such as browsing between different tabs. And as shown in Figure 2 here, separating the constructive actions taken within Part Studio and assembly, we can further divide them into either sketches or features in a Part Studio, and either features or rendering in an assembly. And with a trial experiment conducted with our researchers, sample data were generated for our preliminary analysis. And some of the results are presented here in Figure 3 and Figure 4 as an example. So Figure 3 here shows a comparison of the number of constructive actions that were made by each participant in the experiment. And Figure 4 shows a possible type of analysis comparing the distribution of actions in Part Studio between different participants. And similar comparisons can also be made on any other types of actions along the classification tree here on Figure 2. Besides, researchers also have the flexibility of analyzing these data in terms of like teams or on individual participants. In general, these results are demonstrating the capability of using this method to visualize students' performance in each stage of the design process. And comparing actions in different categories, educators can also tell if a student has explored a specific part of the software to a sufficient extent. Thus, a multi-user CAD software is capable of being a learning platform for future engineering education. And besides working with all of these analytic data, a post-study survey is also designed to be sent out to all participants in such teaching experiments. Through qualitative coding of the responses, we expect to uncover any insights of such learning methods and any dissatisfactory experience from students' perspectives. after all, it is also possible for researchers to use these responses to verify findings from the quantitative analysis. So the next important step of our research will be on conducting a full-scale teaching experiment on students with varying CAD experience by grouping them in different combinations. And by analyzing these practical experimental data and survey responses using the analysis model that is proposed in this research, we expect to find the optimal teaching approach for novices as an introduction to CAD modeling while working with a teammate. So with this new collaborative CAD platform, traditional engineering education on CAD modeling can be augmented by providing students with cognitive apprenticeship training, which has been shown to be able to lead students to more successful problem solving. And now I'm open to any questions.
All right, thank you, Felix. And then,
thank you.
Professor Amami, do you have a question?
Yes, maybe again a short question. Yuanzhe, Felix, both names are good to me, no problem.
Yeah,
can you tell me how figures 3 and 4 would have been to conclude that a collaborative multi-user CAD is not able to be a learning tool?
Oh, so like the point that I'm trying is like they are able, like this platform is able to be a learning platform for students.
My question is, what is specific with these two figures that made you reach this conclusion? If you wanted to reach an opposite conclusion, what would these two figures would look like?
Okay, so so if this platform is not able to, like, it's not capable to be used for students, we will see no trend or no like obvious pattern that. So for example, here on figure 4, we can see like most students would have spent like a quarter of their actions on sketching related actions, and then like another 3/4 on Part Studio features related actions. And if let's say one student only had his actions recorded in sketching related, but nothing recorded on Part Studio features related, then that means this platform is not really capable of recording all the actions that were conducted or done by these students, because those numbers wouldn't make sense for the design that this student has made. Does that answer your question?
I'm not sure. I mean, I couldn't really understand the scientific evaluation of the experiments, but I think such investigations require rigorous tools for evaluating the results in order to come up with such broad conclusions as to a tool is whether or not a tool is capable of being used as a learning tool. Because sometimes we talk about suitable tool, sometimes we talk about a capable tool, something that can be used. And I think more rigorous investigations are needed to get there. But nevertheless, I take it as you mentioned.
Yeah, so like another point is like we're using this software because it records all of these actions as analytic data, which is not common in other CAD softwares. So this is like a new way for educators to visualize their students' performance while not being with them the whole time.
I see. Thank you.